Advent of code, and the puzzle unlocks in a minute. And we'll see whether I can get it done in about an hour and a half, because if not, this is going to be a two-parter. I also may be slightly distracted. I've got Eve over on this other screen because I'm in the middle of doing something that I didn't quite finish up before it was streaming time, but so it goes. All right, 25 seconds left. I will be simultaneously reading the puzzle and also flying my ship around, which you can't see because operational security is important. Okay. So here is the puzzle. We find the friend who is a reindeer. Ah, there's the reindeer that was in the diagram from the first page. Experimental teleport. Okay, so we can transmit to a certain location. Has the largest signal radius and has the most nanobots in range of itself. Great. Okay. So it's just the highest radius, and we can figure out how many things are in range. Okay. This doesn't really seem that bad at all. So, yep. Okay. Let's do this. Right. So I need something like that. Make sure it has the correct number of lines. Yep, that looks correct. All right. Okay, so yep, swap that around. And how are we going to parse this? I think I can parse it by just separating every time that there is a bracket, a comma, or an equal sign. Will that work? The alternative is, you know what? Let's just do it this way instead. It'll be cleaner. Okay. So, type drone struct has a XYZ int, and it has a string int. Okay, good. Finished the Eve thing that I needed to get done. Okay, so what do we have here? We're also going to need some kind of a that, which is basically compute the Manhattan distances and figure out whether they're in range, because those are just strictly Manhattan distances. Okay, so something like that, and Z, okay. Same thing here. I know I could use math abs, but I don't like floating point. I, in fact, detest floating point, unless I strictly need it, so we're just going to need to do this. Okay. So find it cleaner to read things this way. Okay, cool. Now, how do we parse this? Okay. Okay, the other thing I need to do is, how do I want to keep track of these? I guess I'll keep track of these by, keep track of these in the order that I see them. Okay, good. Hey. Hey, 9. Good to see you. Yep, that should do it. Okay. And then I'm going to need to trim off the first one. Actually, let's do that. Okay. 0, 1, 2, 3, 4, 5. Yep. Okay. Okay, that should do it. Now, okay. YZ, 1, 2. Okay, so let's just check this. XYZ and power. Okay. Let's make sure that I parse the first one correctly. Does that work? Target up. Okay. Does that look right? 6.5, yep. Okay, that looks good. Parsing job is correct. So so now like that, and okay. All right. If drones in range plus okay. So it's run it. No field strength. Then in range, oh, capitalization bites me again. Drones in range. And that is my keyboard annoying me. Okay, oh, and now I don't want this piece of debug out. Okay. Do I count myself as in range? Less than or equal to, that's also a problem. In the example, I do count myself. So we'll do that. Good enough. That's correct. Great. Part 2. We need to be within range of the largest number of nanobots. Find the coordinates that are within the range, and then the shortest Manhattan distance. Okay. Fine. Okay, this one's going to be a quickie. This should not be a problem. I'm actually frankly disappointed, given that Eric promised that the last 3 days were going to be really hard. Okay. So now, we need to search the search space. Good night, Lydia. Okay. So all right, so we need to keep track of the bounds of where we're searching. In fact, what I'm thinking is what I basically want to do is roughly, I want to do a linear search almost. Okay, so these values are ridiculously high. It does not make sense for me to try to walk through by X, Y, and Z. So instead, what I want to do is I want to identify some candidate points to start off with. Okay. Oh, those things have absurdly large radii too. So how can I tell whether two drones even have a possibility of their spheres in overlapping? Okay. All right. Yep. Let's think about this. Okay. So let's see. What I want to do is I want to hypothesize that the point that I'm initially looking for is going to be somewhere along the midpoint. Also, I'm going to change this really subtly. do this. Okay. Now let's see. I think that should still work. Okay. All right. Okay. So let's test a few theories. How do I... Okay. Let's just make sure this still runs. Range is declared not used, that's fine. DNT not used, okay. So let's do something to calculate the midpoint between two things. So actually, we're going to want something like this as well. Yeah, in fact, actually, let's do it this way. And now we also are going to want something to calculate the midpoints. Okay. That code stays the same. That code is different. Okay. All right. Oh, that is... Yep, okay. Okay. Let's see. So that computes CX minus TX. Okay. That might work. Or that might have the polarity reversed. that. So if I start from 550, for instance, or 555, and I'm averaging it with 000, I should wind up with 222. So it'll be positive 5 minus 0 is 5. Yep, okay, that seems to be correct. Great. Okay. In fact, if I were doing this in a more sneaky way, I just do... I don't even know why I did it this way. Yeah, I'm silly. Okay. So let's see. Let's start off by... Okay. Want to get a flavor for what this puzzle is like. Okay, let's see what this looks like real quickly. That applies to coordinates. Okay, how many drones are there? There are 1,000 drones, so this is not too bad. This is essentially going through a million different things. So, okay, so that generates results fast enough. So there are some good initial starting places. The question then is, starting from those points, can I walk any of them closer to anything else in order to get in range of something else? So let's see if we can make sense of this. So almost the algorithm that I think I want to use goes something like this. I start from a given point. I'm going to mid it with every other point. I'm going to... So this is almost like I'm binary searching the space repeatedly. I think I actually feel okay about this. Yeah, I actually think I feel okay about this. This seems like an approach that'll work, so let's write this down. I think that makes good sense. So now, for each drone, I'm going to report the distances. This is an interesting problem construction because it has to be made so that there is exactly one solution rather than arbitrarily many, which is interesting. Okay. So we're going to try this. So first, okay. Okay. So let's think about this. So I want to midpoint, or do I just want to move it close enough to get within range? I think I just want to move it close enough to get within range. I will ask Eric about that. Okay. Fine. Something like that should do the trick. Okay. think about this. How do I do this? Okay. So I can do something like this. This is one of the first problems, I think, where I don't know what algorithm to write, as opposed to knowing what algorithm I can write and just tripping over the implementation thereof. Okay. So let's see. Okay. I'm going to have to define a candidate data type. But that looks functionally like a drone, but it's not one, and therefore we need to keep it separate. Location distance. All right, let's see. So I think that should work. Okay. I think that should work fine. Yeah, that'll just take more passes, but I'm okay with that. Okay. All right, something like that should do the trick. Okay. Now, after I've worked this out, we need to take that. What's the sort package? How does that work? Just want to run the sort function with a lambda. How do I do that? I know I've seen this somewhere in here. Okay. Distance, yeah. Okay. Okay, something like that should work. Hey, Colin. Okay. take the top two and put them in the pool. So let's all right. So let's see how that looks now. Right. Okay. So now let's make sure. Let's just get a sense of what we're processing at any given time to see whether we're getting any closer. Right. Line 55, what did I do wrong there? Oh. All right. Coordinate independent. Okay. Why did I need to know the distance? I don't even know why I was doing that before. I'll find out. In my work list. Oh, my work list is literally a list of coordinates. Okay. Okay. So am I actually improving on my metric? That's my question. So if I'm still making progress on my metric, then it seems like I'm getting somewhere. So let's check that. How do I keep track of that? Okay. So let's see whether we're improving. Where's my other print? Does that work better? Okay. So I think the other thing I want to do is I want to keep on iterating on the thing that's within the range of the highest number of things. Is that workable? The other thing I can do is I can just read the first thing off. Let's see how I do. Okay. So if we've decreased our forking factor, we also want to candidate. Let's try this. Sort these by the number of things that are they're in range of. Let's see, that was going to be ranges look. Okay. Let's try using a heuristic like that and then sorting it. Now, how does that look? Oh. So, I need to sort greater to lesser, otherwise I'm going to always be working on the least important items. Smallest distance here, greatest number of things in range here. Are we making progress or not? Okay, let's see. How does this work now? Yeah, I'm not sure. I'm not sure at all. Okay. Yeah, I have no idea. Okay, Well, clearly, anything less than 889 can just straight up be skipped right over. So I suspect that I'd be better served starting from there and seeing if I can get in range of anything else. So in fact, yeah, let's just, instead of giving it a messy one, let's give it no, that's just the highest signal radius one rather than the one that is in range of the most drones. Okay, well that's fine. I'm just gonna hard code this. Why is this code not working? I'm now curious, based on A9's comment, has someone solved it today? Okay, 25 people have solved it today, so fair enough. Right, that seems fine. Yeah, that's okay. So I'm pending every drone as initial starting place. Let's just try setting a different cutoff. If I do this. No. Okay, so it turns out that moving too far is a problem. Yeah, I don't know how to deal with the... I don't know how to deal with this situation. I think the only thing that could help me here is knowing that in order for the solution to be unique, oh, if there are multiple, choose the one closest to your position. So no, there's not a singular unique position necessarily. Okay. Oh, I see. How many nanobots are in range of its signals versus how many... how many nanobots are in range of its signals versus how many nanobots can reach that position? Those two are very different questions. Now I see. Now I see. Okay. Okay. So let's see how this goes. Let's do that and see what happens. Okay, so that's at least vaguely deterministic. like to do is, instead of using the midpoint, what I'd like to do is I'd start walking it in that direction, but only far enough to reach that point. How can I walk it only far enough to reach that point? Okay. Let's see. Right. Am I only using midpoints in one place? Yes, I am. Okay. Okay. All right. Going to walk it one in every direction until, no, I need to do it proportionally. All right, so we'd rather verge on walking too far rather than too close. Okay. Fine. Alright. This is annoying, but I don't want to modify these. Right. Cool. What am I walking partway starting from? Starting from the adjourn we're trying to reach. Okay. So now that makes sense. We're starting at 5, 0, for instance, and we're trying to walk towards 0, 0. Then, nope. Nope, these semantics need to be that way. Okay. Is going to be okay, so times d divided by sum. So if I'm supposed to walk, if I know I need to walk d steps towards, then I need to walk d steps times x delta divided by, yep, I think it doesn't change the logic, it just, let's try that. Ooh, that's looking promising. Okay, so that looks pretty good. I think now, let's see, does this cut off possibilities? Yes, it does. Okay. Oh, I'm glad that you're enjoying Walsh. Can I get there in one step? Interesting. Curious what I can't bother with. Why does it get stuck on a pessimal outcome? So this should be sorting it correctly. Okay, so this shouldn't work at all. That theory. Yeah, okay, so at a certain point running this filter won't work. See that? Okay. Does it progressively get any better? So once I have a candidate point, then I need to figure out how close I can get to 0, 0 and still be within range. So let's see. No, I need to seed it with a sufficiently close value. So now see whether I can dynamically adjust the threshold upwards as I go. Okay. So if that hypothesis is true, let me just test multiple conditions. Let's start it at 0 and see whether this ratchets correctly. Oh, nice, it does. So it finishes at 826. What happens if I set high score to 823? Does that work? I can find something that's within range of 828. Okay. So that does that. If I run it n-seeded, what happens? I get some values that are in really interesting places. All right. So let's start there and assume that that's likely to be in the neighborhood of my solutions. So the question is, can I continue walking back towards 0, 0 and not fall out? Okay. But I can. So those are going to be it's not going to be worthless, it's going to be ranges. If V is not equal to high score, continue. Okay, let's comment that out and take a look. Alright, so let's see. So that generates the points that we expect. In fact, that generates all of the points that we expect. So now, actually, let me deal with this. Oh, interesting. That yields a better result, I think. Let's find out. $829. Is $829 better than $889? No, it is not. I'm just wondering if I have an off by 1 error. No, I don't. Okay. Wait, oh, that's 829. That's even better. Let's see. 29. 829. Okay. Cool. Let's continue forking a little bit more now that we know that that's a possibility. Nope. Have a look at that. Ah, clever. Okay. So that's still giving us values that are roughly in the same ballpark. Okay. So okay, that seems fine. Let's test that. Oh, 831. That's even better. 837. 35. How did I get 837? That generates 879 adjacencies. That's even better. Can I do better than that? Nope. playing around with values to see whether we can get anything better. Okay, so those are some really interesting starting points. I'm going to take a guess that the result that we're looking for is somewhere in this vicinity. So the question is, I take one of them, I subtract from it, is it still in range? Okay. Let's try one more thing now that we've manipulated this. Let's check that. Oops. No, that still is 879. Is that 879? Yep. Okay. I think I feel most comfortable with accepting that. Okay. So some make sure that this works. Type chord has no, oh, we don't need that. Okay. This is just a complete shot in the dark. Oops. Why is that not correct? Does that work? Oh, because I'm starting, so I'm just going to set it to an absurdly high value. Yep, okay. There we go. Okay, so now we have a starting point. So now we can start taking off values and seeing if we can get closer to 0, 0. Okay. All right. So we need to goodness. Okay. So let's see how much smaller our wiggle room is here, for instance. Not equal to high score. Okay, so I have no wiggle room there. Let's see if I have any wiggle room here. Okay, I have no wiggle room there. Do I have any wiggle room here? Nope. Okay, well, I think that settles that. Let's try that. I expect this fully to be wrong. Wait, that's correct? Holy crap! Rank 64. Oh my god. I did it? This code is messy. There's no way this should work. And yet. Okay, well, I am stunned into being speechless. Thank you for cheering me on, everyone, and have a good night. I'm going to check this code in and marvel at how it even worked. Have a good night, folks.